Have you ever watched a sci-fi movie and thought, wait, could this actually happen in real life? Today, we're going to break down 3 legendary films that stand in a league of their own: 2001: A Space Odyssey, Interstellar, and Project Hail Mary. These movies may look like pure entertainment, but the truth is, they're built on real science. The first one draws from the knowledge of the 1960s and the ideas of Arthur C. Clarke. The second is grounded in Einstein's equations of general relativity as interpreted by Kip Thorne. And the third relies on modern astrophysics, relativistic physics, and even exobiology, all thanks to Andy Weir. Each of these films is in some way my favorite space film. We'll examine exactly what real science lies at the heart of each film, where the creators stayed true to their facts, and where they made smart, reasonable leaps into speculation. Let's dive in. And the first film is 2001: A Space Odyssey, directed by Stanley Kubrick in 1968. This 1968 movie is a true masterpiece of realism for its time. Stanley Kubrick and Arthur C. Clarke worked closely with NASA scientists and other experts to portray space as accurately as possible. First, artificial gravity. The rotating centrifuge module on the Discovery spacecraft isn't fantasy, it's real physics. Centrifugal force inside a rotating habitat creates the sensation of weight. Concepts like these were already being discussed in NASA projects back in the 1960s. Even today, it remains one of the most realistic ways to simulate gravity for long-duration space missions. Second, the silence of space. Explosions and engines make no sound in a vacuum, and that's exactly how it should be. Sound needs a medium to travel. Kubrick captured this perfectly, using only music and the sound of breathing inside the spacesuit. Third, the long journey and hibernation. The crew members in suspended animation were based on real engineering ideas for conserving resources during interplanetary travel. The Discovery's nuclear propulsion system also draws from real concepts, echoing projects like NERVA, HAL 9000, the artificial intelligence. In the 1960s, this was still speculation, but it was rooted in real scientific thinking about AI. Marvin Minsky even advised Stanley Kubrick during development. Today, neural networks are beginning to approach some of HAL's capabilities, though true strong AI remains far beyond our reach. HAL's conflict reflects a classic dilemma. What happens when a machine is forced to reconcile contradictory priorities? The mission versus the truth. The monoliths are pure philosophical speculation about extraterrestrial intelligence, yet the film's approach to evolution and contact with alien minds was influenced by real scientific thinking of the time, particularly ideas explored by Arthur C. Clarke. Overall, 2001: A Space Odyssey remains one of the most scientifically accurate space films ever made, particularly in its portrayal of physics and engineering for its time. Drop by my website if you love movies. I share my reviews and thoughts on films there, plus lots of other cinema articles. I read it regularly and with passion. I'd love to see you there. Interstellar 2014. Here, the silence reaches a whole new level. Physicist Kip Thorne served not only as the scientific consultant but also as an executive producer of the film. He personally ensured that nothing violated the fundamental laws of physics. So now, let's talk about the black hole Gargantua. Its visualization wasn't created by artists, by eye. It was generated by solving Einstein's equations of general relativity. The visual effects team used real calculations of how light rays behave in warped space-time. The result was so accurate that the work on the film even led to new scientific publications. The gravitational time dilation on Miller's planet is a completely real effect from general relativity. The deeper you are in the gravitational well of a massive object, the slower time flows for a distant observer. 1 hour on Miller equals 7 years on Earth. This isn't fiction, it's a direct consequence of Einstein's equations. Wormholes are theoretically possible within general relativity as bridges, connecting distant points in space-time. According to Thorne, keeping a wormhole stable and traversable would require exotic matter with negative energy. This is still speculation, but it's mathematically permissible. Gravitational slingshot maneuvers around the black hole and relativistic effects in the accretion disk are also real astrophysics. Even the blight, the disease destroying crops on Earth, is a reference to real-world issues of food security and the potential consequences of climate change. Let's now discuss the movie Project Hail Mary. The Project Hail Mary, the 2026 film based on Andy Weir's book, the author of The Martian, is the pinnacle of modern hard sci-fi. The central threat is Astrophage, the star eater. This fictional microbe feeds on stellar energy, dimming stars and triggering global cooling on planets. The idea was inspired by real extremophiles and photosynthesis, algae and purple bacteria. The concept of spores traveling between stars belongs to speculative exobiology, but Weir made it remarkably internally consistent. How does Astrophage move? Through near-perfect conversion of energy into mass and back again via instance E equals mc squared. It stores energy as mass and emits directed infrared light for thrust, essentially a photon drive concept that is seriously discussed in real science, for example in the Breakthrough Starshot project. Its cell temperature is strictly fixed at approximately 96.4 degrees Celsius, a clever engineering trick for thermal stability. The interstellar journey aboard the Hail Mary uses Astrophage as fuel to maintain a constant 1.5 grams acceleration. The rotating module for artificial gravity is once again based on centrifugal force, just like in 2001: A Space Odyssey. The destination is Tau Ceti, a real star 11.9 light years away, one of the closest Sun-like stars. Weir chose it deliberately because it is relatively old and stable. The planet Adrian and communication with the alien Rocky are pure speculation, but they are grounded in real exoplanet searches and ideas about possible non-carbon or microbial life. Tomoba, the predator of Astrophage, is a classic biological concept of ecosystem balance. The entire story is built around the scientific method, hypotheses, experiments, mistakes, and collaboration. This is Weir's true philosophy. Science wins through rigorous testing and teamwork. The drawbacks: some properties of Astrophage, especially its super cross-section for neutrinos, represent a significant creative leap at the quantum level. However, Weir built an entirely self-consistent world around it. Most astrophysicists agree the physics of interstellar travel, relativistic effects, and artificial gravity rest on a very solid scientific foundation. So, what unites these three legendary films? They clearly demonstrate one important truth. Great sci-fi is not born from empty fantasy, but from a deep respect for real science. 2001: A Space Odyssey is all about engineering precision and the eerie silence of space. Interstellar reveals the breathtaking beauty and strangeness of Einstein's general theory of relativity. Project Hail Mary celebrates the triumph of the scientific method, biology and human, and sometimes non-human ingenuity in the face of a global crisis. These films have inspired entire generations of scientists, engineers, and astronauts. They remind us of something crucial. Space is incredibly complex, but it is knowable. We're already launching powerful telescopes like the James Webb, discovering thousands of exoplanets, and seriously thinking about interstellar travel technologies. So, which of these three movies do you think is the most scientifically accurate? Let me know in the comments. If you enjoyed the video, don't forget to like it, subscribe to the channel and hit the bell icon so you don't miss future breakdowns.